So let's wait for others to join. If they join, then we'll start after 5 minutes. Let's see. I'm audible, right?
Yes.
Okay. Okay. I'll share my screen in a while and start. Is my screen visible? Hello. So last week and this week, I think up to delay aware system design controller design is covered. So I will take you through the lecture material once, then we'll solve some problems like we do for all the classes. And meanwhile, if you don't understand some part, please let me know. Okay. So, any specific part that you have problem with in the last week's lecture, not this week's? Hello. Hello, am I audible? Is there any part that you would like me to explain specifically where you were stuck for the this week's lecture or last week's lecture? I'll focus on those parts then. I mean, solve examples on which state space design.
Assignment problems, they're very difficult to solve.
So last week's assignment problems were okay after the tutorial, scheduling and everything. You were able to solve somewhat.
No, see, problems in the sense we are
Mhm.
getting theory, but I am not able to solve
N- n-
I am not able to solve the problems of assignments.
Fine. I'm telling about scheduling part. After having the tutorial, we solved some problems there, right? So were you able to?
No, last time I could not join you because your link was there, but
No,
I
no.
tried for
Last
one.
Saturday, no, no. Last Saturday, I mailed everyone that I will have a class together in the next week. Last to last Saturday during scheduling, about the scheduling, I'm telling that
That is okay,
that
but
was okay.
last
Hmm.
last assignment also I scored very less
Okay, okay, okay.
marks.
So the assignments are like weekly you have to complete, or you can complete
Yes,
anytime.
yes, weekly,
Weekly you
weekly.
have to complete. Okay, okay. So last week's tutorial was mostly on, I guess, state space model design, system design. So I think some examples on state space system design were given in this slide itself, but I'll go through the basic ideas of how to design the systems and everything. So these parts you will already know since you have a control system background, I am guessing. But still, if some other people join for them also, those who are not aware, I mean, they don't know about this part because this is not typically computer science. So basically, when we are designing a system, any system, uh, when you are designing any system, they are basically any dynamical system that you are going to design, they're basically some variables that are changing with respect to time. So that is how we model any system, and that is like our ordinary differential equation. And when we are solving in this course, mostly we'll contemplate on the part where we are discretizing the system and then making the controller of the system. That is the part that is we are interested in. So for example, if I consider this DC motor, so basically before going to this example, I'll just quickly scroll through the PPT. So basically when we are designing a system states, what a system states basically depends on what are you trying to control. So if you are trying to control a particular variables of a system, that particular parameters of the system, and you have certain desired value in your mind, you want that particular parameter or the particular variable to reach that particular value, you have to you have to force it. So it will not naturally go towards that value. Depending on if the system is stable or unstable, either it will converge or diverge. And even if it converges, what do I mean by converging and diverging, that I will explain. Even if it's converging, then also there can be problem, I have to force it. So basically there can be multiple states in this process that we have to consider in order to compute. Maybe I am interested in that this particular state x1. For that I may go through some other states, because I cannot design a system directly having a state x1 with ignoring some other states that are already coming in the way. So basically some states we will observe, and based on those observations we'll control that particular state. But in between there will be some hidden states that might not be measurable or might be measurable, but they might not be of my interest. I need to control a particular state among those observable states. So observable states are basically expressed as y, or output states. So these are basically the internal states of a system. If there are n states, maybe there are m observable states or m output states that we need to observe and compute control for. So this is how they are expressed, and mostly we'll work on linear systems here. Now linear systems are more complex, so we'll start with linear systems. And obviously they are linear time invariant system. Linear system, you already know, they have these two properties, additivity and homogeneity. Obviously if these are the two properties for additive and being additive and homogeneous. For nonlinear system, again these equations for the change of the variables will be nonlinear. And I'm not going into these things. Obviously these things are already there in the slides, so I'm not going through them. But there can be questions from these categories and these things, but these will be doable, I think. So plant controller model, yes, the what I was saying, basically some system input will be there, output will be there, and environmental disturbances will be there that will be stopping me from achieving certain desired value that I want to achieve. So I have to force the system towards it. So that is what we are trying to do by designing a feedback control system. Basically feedback is something that we are getting from as the system output. So always there will be like we discussed in our last other classes as well, that actuation, sense and computation, these are the three parts of the system. So sensing the output variable that I want to control, or maybe is more than that, other variables also maybe. So sensing them, computing a control law that will send this sensed variable towards a reference value, and then I'll actuate those particular control inputs in the to the car. So usually a driver kind of when a driver is driving a car, he is basically controlling the car as he wishes, he or she wishes. So basically if you want to make it do it autonomously, then you have to design a controller for that. That is how the controller cards are designed. Obviously now these are the three primary things that we have to take care of. uh, among obviously others. There are other things like safety and sensitivity. Those things will be coming to those later, but basically these are some of the primary things that we have to take care of when you're designing a system. So stability, performance, these two will be part of the lecture when we move throughout the lecture. So open loop system. So open loop system is basically where we don't have a feedback loop involved in the system. So the process is running by itself naturally. So be it a stable process or be it an unstable process, depending on how its behavior is, it runs automatically. We are not forcing it towards something based on the feedback or using some other logic. So basically we are not using the feedback, we are directly using some inputs, giving some input signal. That input signal will be depending on some other values, but we are not taking considering the feedback from this loop, from this process. So this is called an open loop system. And closed loop is basically taking a feedback from the process, how the process is reacting to this input that I am sending, control input that I am sending, and based on the feedback, I measure what should be my next action that I decide from the measurement of the output. So basically, I compare where I want to go, what is my desired output, and what is the output that I am achieving now. And based on that comparison, I modify my control input, and accordingly, I force the system towards a certain desired output response. So that is the idea for most of the system. You will see that is the idea, be it a missile launcher system or be it any other system. We'll see some modeling of system in the tutorial. So these things you already know, I am not going to. These are very straightforward block diagrams that you can see. Here I am trying to achieve this reference input, and here I am trying to find out how far I am from that reference input, and based on this error I am computing the control input that I should inject to the system, actuate to the system. I should not say inject. When I'm actuating, there may be some disturbances involved. So maybe where I'm supposed to reach, that will help me, not, it will not let me reach that particular output in several iterations. So I have to try, and after certain number of iterations, I'll be able to reach there. So